Hello and welcome to this lesson about surface area of cylinders and pyramids. The learning target for this video is using nets to find the surface areas of cylinders and perimeters. So let's talk about what a net is. A net is a 2D drawing of a 3D object. And so for example, if we were to take something like a cube and we want to draw its net, it might look something like this, where we take 4 of the 6 faces and we put it like that, and then you put it like that. Now the thing is, all nets, or all shapes could have several different nets. But what the net's greatest tool is, or its greatest use is showing us sort of what it looks like what the shape looks like if it was flat. And this is helpful for calculating the surface area of different objects. This is especially the case when we look at the cylinder. So a cylinder has circles at the top and at the bottom. Let's make that a little cleaner here. Like that. Now, what we have to do is we have to imagine cutting this thing open and seeing what we would get. And here's kind of cutting off all these different pieces. So what we're going to do is we'll get the 2 circles, and that will still very much be part of it. So just kind of imagine like lifting that off of both of these. Then we're going to cut along where this red line is and really open up what's left. And what ends up happening is we get something that's super duper long like that. And that right there could be a net for a cylinder. Now when it comes to thinking about the surface area of a cylinder, let's kind of break it down piece by piece. So the surface area is going to be the area of these circles. Pi r squared, pi r squared. So we have 2 of these, and to kind of show that, I'm going to put it in parentheses, 2 pi r squared. So that has to deal with the 2 circles. Now, this part is where it gets a little bit interesting. This is why we want to kind of cut it open and be able to see the net. Before we had cut it open, we have the depth, or perhaps the height would be a better variable in this situation. So that's going to play a part in it. We'll definitely have this h. And when we've cut open this cylinder, we turned it into a rectangle. So we just need to times our height by whatever this length is right here. Well, that used to be a circle, like I keep pointing out here. But the thing is, it's the circumference of the circle. So it's height times your circumference, which is equal to 2 pi r. So we'll have height times 2 pi r. So that's the formula for finding the surface area. Now, let's actually put it into application here. So let's say we have, for an example, a cylinder that looks like that. And we're told its radius is 4 centimeters and its height is 6 centimeters. Okay, so what we're going to do for this is just kind of going to break it down. We have several pieces. I really want to show that to you, so we're going to take our time. We have the top circle and we have the bottom circle. So the surface area will equal the area of the top circle, which would be 4 squared pi. And then there's 2 of these, so we'll put a 2 right there. Now we need to find the area of this part right here. And again, that's where the net comes in handy, where it's a really long rectangle with the 2 circles on top, or 1 circle on top, 1 circle on bottom. This part is your h, so in this case, that's going to be the 6. So plus 6 times, and then we need to get this length, which we said is the circumference of the circle, which is 2 pi r. So going back to our formula, that would be 2 pi times 4, our radius. Now we have all the pieces. We have the 2 circles that represent the top and the bottom, and we have all that space in between it. So now we just have to crunch those numbers. So when I do that, I'll end up getting, let's see here, so this one is going to get 4 squared is 16, times that by 2, I'll get 32 pi, plus here I'll have 2 times 4, which is 8, and then times by 6 is 48 pi, and now I have to multiply all this out, and so let's see here, this gets me about 100.48 plus 150.72 when I use 3.14 for pi. Add the two together, and we have 251.2 centimeters squared. And so that's how we find the surface area of a cylinder. Again, what we have to do is catch on to this main idea right here, is that when we cut open our cylinder and stretch it out flat, we get a rectangle, and that blue line is a circumference. Once we have that, then it's just about adding the smaller or the other pieces together. Now, let's continue. Let's just take a quick look at some pyramids here. Now remember, we have two types of pyramids. Fortunately, it doesn't matter which type we have. So we have our triangular prism pyramids, where the base is a triangle, and then we have our rectangular pyramids, where the base is a rectangle or a square, and whatnot. But either way, we're going to use the same process, which is to make a net and add all the areas together. So let's crack open this guy here first on the left. When we do that, we're going to have 1, 2, and then back there, a third triangle. 1, 2, oops, my drawing's a little bit off here. 3. Then down here, we have that fourth triangle, which represents the base. At this point, all we would need to do is add them all up. Similarly, we would do the same thing for this one. This will be a little bit easier to draw because it's got a square base, so we'll get our net to look like that. And then again, we have to calculate the areas of all those all the shapes and add them all up. So for our final example, let's take a look at this one, where we have a square-based pyramid, where the base is 8 by 8, and then this light blue line, to kind of give it a fancier phrase, is what we would call our slant height. And that refers to the height of just this triangle, not the actual height of the whole thing. Those are two different things. But we need that slant height so we can calculate the area of this triangle. Now, if we were to just kind of make a rough sketch here, we would end up getting something like that for our net. We know that this is 8 by 8, and then the slant height tells us that this is 12. Now, if you want to, you can maybe kind of group some of these triangles together, but I'm going to be extra careful, and I'm always going to multiply everything by 1/2 that I need to. So first, I'll add up the area of the square, or find the area of the square, because that would be the easiest. So the surface area here would be 64 for that, plus, now I'm going to find the area of each of these triangles. So 1/2, 8 times 12. Again, if you're feeling adventurous and confident, you can just, at this point in time, multiply that by 4. But just to kind of, do good measure here, I'm going to show that I'm doing this for all of these. So, because that's 12 on all of them. The base is 8 on all of them. So, plus 1/2, 8 times 12. Now, you're going to be careful as if you have a triangular pyramid and perhaps they have different base lengths. In that case, these calculations may be a little bit different here. So 1/2, 8 times 12, just snuck it in there. Perfect. So now let's crunch all those numbers. We have 8 times 12 is 96. Half of 96 is 48. So 48, 48, 48, 48. Now, when we add these together, we're going to get 96 and 96. So we have 64 plus 96 plus 96. And that gives us 256 units squared. So again, when it comes to doing pyramids, just take a look at what pyramid you have, break it down into its 2D shape, and then try to find the areas of all the individual ones. Sometimes, if you want to, you can maybe cut a corner and kind of do a shortcut where we just go 48 times 4 and call it good from there, and then add to 64, or just, again, literally write it all out like this, so that way you might be a little more confident in your answer. So good luck on your homework or practice, and let me know if you have any questions.